Hello to everyone, hello to the YouTube community. Welcome once more to another video in our YouTube channel. So in this video, we are going to be looking at a tutorial question on polynomials, specifically on the factor and the remainder theorem. Now the concept that I'm going to be talking about in this video is one of the most minimized concepts by students who are currently preparing for the Cameroon GCE advanced level pure mathematics. Alright, so for those of you who have been with us for some time now, we thank you very much for your patience, your subscription, sharing the videos, commenting on the videos, liking the videos. We appreciate you guys for that. For those of you who are just joining us for your very first time, or you have not been with us for a very long time, please endeavor to subscribe to the channel if you have not yet subscribed to the channel. Now after subscription, make sure you turn on your post notifications so that whenever videos are uploaded to this channel, you always get a notification from YouTube to come and watch. Alright, so in front of you, I believe you can see some series of questions here, because you see question marks there. The first is an integral, second is a derivative, third is a summation. Then you have a graph asking you to look for the function whose degree is 3, and so on and so forth. Alright, so for the third question, which is the question on the infinite sum, that's a sum from n equal to 0 to infinity of ln of 2 raised to the power n on n factorial being less than 2 on 5. The question is going to be solved in the upcoming video. Yes, so endeavor to watch the solution if you can't solve that problem. Now for the other problems, you can get to us maybe via WhatsApp or our email address if maybe you figured out the solutions to those problems, or even in the comment section you can comment your responses, so we give you a mark if maybe it is correct or it is not correct, and we guide you how to go about them. Alright, so pay keen attention to the concepts that are going to be displayed to you in this video, because they are very important. So let's get started. Alright, so the question has just been displayed to you already, but before solving the question, we are going to have a rundown of what the concept is all about. So the question is asking us to look for the integers m and n such that x plus 1 all squared is a factor of x raised to the power 5 plus 2x squared plus mx plus n. So the concept I'm going to be teaching today is the concept of repeated factors. That's if a factor is repeated, because x plus 1 all squared is not just single, it is actually repeated because it is x plus 1 times x plus 1. So we are going to see how to deal with cases like this. Alright, so firstly, I call a factor repeated if it is written in the form x plus or minus a all squared, where a is a real number. Now the next point is that if let me just say x minus a all squared is a factor of a polynomial, then it means that x minus a all squared actually divides that polynomial. Okay, now the next concept is that x minus a all squared divides a polynomial. We can write it in mathematical form. It means that f of x divided by x minus a all squared will give us a quotient plus 0 remainder. So it means f of x can be written as a product of its factors. The first factor is x minus a all squared, which is actually repeated, and the next factor is a quotient that was obtained via the long division, which is q of x. Now things are becoming very interesting now, because if the very x minus a all squared is a factor of my f of x, it means that x minus a is a factor of the derivative of f of x. So it is very important, and that's the concept we are going to use to solve this problem. But before that, we are going to prove why the third point is always correct. So to prove that if x minus a all squared is a factor of f of x, then x minus a is a factor of its first derivative. How do we prove? Now f of x is equal to x minus a all squared times q of x from the third step, right? So let's try to look for the derivative and see what we get. So differentiating, we can use the product rule because we have the product of two functions whose variable is x. So I keep x minus a all squared and I differentiate q of x. I get x minus a all squared times q prime of x plus I now keep q of x and I differentiate x minus a all squared. Now to differentiate x minus a all squared, I drop the power, I differentiate the integral, and then I multiply it with x minus a and I remove 1 from the power. So when you drop the power is 2. You differentiate x minus a, you get 1. So you just 2 times 1, which is still 2. Then you multiply with x minus a raised to the power 2 minus 1. You just get x minus a. Then times your q of x, which was left. So from the two terms, you can factor out x minus a, right? If you factor out x minus a from the first term, you'll be left with x minus a times q prime of x. If you factor out x minus a from the second term, you'll be left with 2 times q of x. So what can we see? It means that x minus a is also a factor of f prime of x, because here is it, x minus a times something else. It means that x minus a is also a factor, because generally polynomials can be written as the product of its factors. So if I take f prime of x, if I divide both sides of the equation by x minus a, on the right hand side I'm just going to get a new polynomial which has the remainder is going to be 0. So that's my new quotient when I divide x minus a on both sides. So it means x minus a is also a factor of my f prime of x. So with that said, our proof is complete. Now, since x minus a is a factor of f of x, it means that f of a is equal to 0. And we can see it by fitting a in the expression of f of x. You have a minus a all squared times q of a. But no matter the value of q of a minus a all squared is 0. So it means f of a is equal to 0. Similarly, we can also see the situation of f prime of a. F prime of a means we should fit a in f prime of x. Fitting a here, we have a minus a. No matter the value of this term inside here, we are going to get 0 at the end, because a minus a is 0. So we see that f of a is equal to 0 and f prime of a equal to 0. It therefore means that x minus a is the factor of both f of x and f prime of x. Alright, so let's now proceed in solving the problem. But anyways, let's look at some common examples. Now we know about x squared plus 4x plus 4 is the same as x plus 2 all squared. So x squared plus 4x plus 4 has a repeated factor of x plus 2 all squared. So we are going to verify if our previous statement is actually correct. So first we are going to verify if f of negative 2 is 0 and if f prime of negative 2 is 0, because since x plus 2 all squared is a repeated factor, like we said earlier, it means that x plus 2 is a factor of f of x, as well as it is a factor of the first derivative of f. So x plus 2 being a factor, it means that x equal to negative 2 is a root, and whenever I take the root and you impute in the function, the output will always give you 0. So f of negative 2 should be 0 and f prime of negative 2 should be 0. Let's begin with f of negative 2. F of negative 2, we have negative 2 all squared plus 4 into negative 2 plus 4, which will give us 4 minus 8 plus 4. 4 minus 8 is negative 4 plus 4 is 0. So it means first is completed. Now what about f prime of x? F prime of x, we differentiate, we get 2x plus 4. We can do 2x plus 4 is 2 into x plus 2. So we have already seen that x plus 2 is already a factor of f prime of x, right? But anyways, let's proceed to get f prime of 2. F prime of negative 2, is 2 into negative 2 plus 2. Negative 2 plus 2 is 0, so at the end we get 0. So it means our previous statement was correct. Now let's dive straight away in solving our problem. So our f of x, we are going to let it to be the given function, which is x raised to the power 5 plus 2x squared plus mx plus n. Now let's analyze together. X plus 1 all squared is a factor of f of x. There are two things. The first thing is that x plus 1 is a factor of f of x, and next is that the very x plus 1 is a factor of the first derivative, as we have seen earlier. Now x plus 1 being a factor of f of x means that f of negative 1 is 0. X plus 1 being a factor of f prime of x means that f prime of negative 1 is 0. Now f prime of 1 being equal to 0, we go to our expression of f of x. We fit negative 1, x raised to the power 5 will give us negative 1, 2 times negative 1 squared will give us 2, m times negative 1 will give us negative m, then plus n, and we equate to 0. From there, we can get an equation in terms of m and n, which is negative m plus n equal to negative 1. Alright, now f prime of x is, we differentiate the function, right, with respect to x. The first time, we get 5x raised to the power 4 plus 4x plus m. Now, since f prime of negative 1 is 0, it means we replace negative 1, we get 5 times negative 1 raised to the power 4 is just 5. 4 times negative 1 is negative 4 plus m equals 0. 5 minus 4 is 1, we add to m and then we subtract 1 on both sides. We get m to be negative 1. So with that said, it means that we can get the value of n, because negative 1 plus n is equal to negative m plus n is negative 1. So we can add m on both sides, we get n to be negative 1 plus m. But since m is negative 1, it means our n is negative 1 plus negative 1. So our n is equal to negative 2. So you see, using this concept of a repeated factor of a polynomial, we have been able to get the constants m and n. So generally, if you never knew about this concept, you have just one equation, because x plus 1 being a factor, it means f of negative 1 is 0, and you just be left with negative m plus n equal to negative 1. But nevertheless, other methods can be used, which will be very lengthy, because problems like this maybe usually come only in paper 1 to test how fast the students can reason. Alright, so thank you for watching. See you in the next video, and endeavor to like the video if the video is good.